Hello friends, we are discussing about how you can convert the categorical data to the numeric data. Like if anything in the data type object, how can you change it to any numeric data type like float or decimal or something else like integer. So we have already discussed why we need to convert the categorical data to the numerical data, but just for recap, I can tell you that it is required because most of the model algorithm prefer to have the data in the numeric data type. So now we have already discussed the label encoding method. So it is the simplest one if you are converting the categorical data to the numerical data, but it has its own problem. Like the direct conversion of the string like A, B, C, D, whatever the ABCD value is, to 1, 2, 3, 4 or 0, 1, 2, 3 is just like if anyone convert it in that way to U also, you will assume that there is a sequence or there is a hierarchy or there is a order of these number. So it is often misinterpreted as like any human body by the machine also or the model algorithm also, and it will derive the weightage from those numerical converted data. So that's why we have introduced the one-hot encoding method. First thing is that why this kind of name, one-hot encoding. So that means one-hot means where it is true, it will be given as 1. Where it is false, it will be given as 0. So it's just a binary, or it will be like a diagonal matrix created from the, like if you have 4 categories, so these all 4 categories will be converted to 4 dummy features, and then wherever the category value is present, that will be 1, and for rest all feature which is created by this encoding method will be 0. So just like in this example, so we have 4 animal keys, right? Dog, cat, horse and pig, and like there is 5, and zebra. So wherever dog is present, it will mark as 1, like 1 is hot. And for the rest of the category, the value will be 0. Here it will be 0 for like if dog is equal to 1, for cat, horse, pig and zebra it will be 0. Similarly for cat, wherever cat is present, that will be 1 and rest will be 0, and same will happen for horse, pig and zebra. So we have this encoding method present in the scikit-learn library, and we will check it using some example. Let's take this example only in the Python, and I will use a Kaggle notebook to test this. Let's go to the notebook. So first thing first, I need to import from scikit-learn, from scikit-learn.preprocessing. So these are all are the steps of pre-processing or the feature engineering. And import one hot encoder, and let's define one hot encoder just like a short form of it. OHE is equal to, let's copy it, and I have not given any kind of parameter to it. So let's first check what is the default parameter, so that is very important, and then we will discuss that what should be that parameter value and what is the significance, what all different parameter value you can provide and what is the significance. Let's check the parameter first. What is the default one? So OHE dot get params. And you see there are like 4 to 5 parameters are given. First is categories. So why it is auto? It means it will derive from the category value. So if I just go back to this example, so for this the category will be dog, cat, horse, pig and zebra. So that will be automatically derived. If you want to put any other value for this category, you can put it like a list here instead of auto. And then the second parameter is drop is equal to none. So you are not dropping any parameter. So like it has a significance. Let's explain it to you. Like you have two parameter, right? So like it's like mutually exclusive, right? For example, you have like gender. So gender can be male or female. So you can write the male or female in the same feature, right? And when you convert it to the like numerical value, this one hot encoder will create two features out of it, right? Two categories. One is male, another is female. And it will be given as like if there are two rows, one is male and another is female, it will given as like 0, 1, 0 and 0, 1, right? But do you really need these two features? Because that is mutually exclusive. So you can drop any one of them or the first of it, and you can keep the other, and you can interpret the data, the other feature data from it or the other category data from the like the mutually exclusive category. So that's why there is an option. So it is coming recently in this one hot encoder parameter list. So it is like you can drop the first feature, or you can choose any particular feature to drop, or you can drop none. So by default it will drop none. Next is data type. So data type is numpy float 64, and you can change it to any other numeric data type. So by default it is float 64. And then handle unknown, it will be like error, and you can put anything like handle unknown is equal to none or something like that. And then sparse is equal to true. That means it will create a sparse matrix, and if it is false, it will create an array, two-dimensional array. Okay. So I will show this example to you. So I want to show it as an two-dimensional array instead of sparse matrix, because sparse matrix is not easy to show. Just for this like few minutes tutorial. Sparse is equal to false. Now you have the sparse is equal to false. Let define my train data. So remember, one hot encoder will accept only two-dimensional array. If you give a one-dimensional array like level encoder, it will throw an error because it is expecting two-dimensional array. So let's create a two-dimensional array. So here, why two-dimensional array? Because it is converting the row to the column. That's why it will expect in that fashion. You may or may not provide any other feature value. Whatever you want to convert only, you can keep it like just a one column table kind of thing. So that is kind of two-dimensional matrix, right? So I will create the same, like I will create dog and then cat and then horse and then pig and zebra. And I close the two-dimensional array. So this is my trained data set, and let's fit my one hot encoder with this data. Dot fit, and let's transform the same trained data. It's not a good practice, but I am doing it just for the sake of showing you too quickly. And put, so let's go train, and you see, have you interpreted anything? I have said like it will be like a, you know, diagonal matrix, so it is not creating a diagonal matrix. Let's see what all categories it will create. So by interpreting that only you may understand this matrix or the two-dimensional array. It's not a matrix, it's a two-dimensional array, and I am reading it like a matrix. So what you can do, one hot encoder dot categories. So this is an attribute, you can check, and you see these are my attribute and the data type is object, because categorical data type will be object only. So cat is the first, not dog. So it is, I believe it will be in the alphabetic order. So cat, dog, horse, pig and zebra. So this is in this categorical order and like in alphabetical order. So is cat present in the first row? No, it is dog. So it will be 0 and it will be 1 for the first row. For the second row, is cat present? Yes. So the first row will be 1 according to this array. So let's take this as my header. Okay. So it will be 1. And for the second row, for the third row, what is present? Number 3. What is number 3? Horse. So yeah, for the third row, horse is present. For the fourth row, pig is present, is also in the fourth one in the list. So for fourth row and fourth column, pig is present. And zebra is the last row and the last column, like when it is converted to the numerical feature. So it will be last row and last column. So if you provide the data in this fashion, you will get the diagonal matrix, but like to explain it easily, I have shown you in the diagonal matrix. But the thing is like the attributes which are automatically generated is in the alphabetical order. Let's add one more row, like another dog. So it will having like 1 for the last row and the second column, or the column will be second and row will be last one. So you have easily understood like how it is converting the categorical data to the numerical data. And since it's one hot, that means it's just a true and false, and everything is having one value, it will not interpret any hierarchy or order or precedence or weightage from this conversion or the encoding. But there is a problem. You know, if you have like less cardinality in this feature, do you know what is cardinality? Cardinality means how many various category present in that feature. If it is less, then number of column it will create automatically or through a list will be less. If you have n number of categories in a feature where n is very high, it will end up creating a very robust table, right? Because it will convert all those variants into columns, and it may create a performance problem or the resource problem because it is abruptly increasing the table size. So try to remember this point. There is another method to create it, like to have this one-hot encoding without using the scikit-learn one-hot encoding library. So you can like use the dummy variable, like it's in the pandas data frame. Using the pandas data frame you can do it. I will explain it in some other video, but this is how the like scikit-learn one-hot encoding library will work, and these are the parameters and the various parameter value you can pass that I have just explained. Please leave like and subscribe. Please like click that subscribe button as quickly as possible, because I am coming with more and more videos in this topic, and it will be really interesting for you guys to follow this video series, because I am also a detailed learner. I am not satisfied myself until and unless I get the basic. So I will try to provide the same to you guys also, so that machine learning will not be a like fearful jargon. It will be your friend and your helper in getting a new job and doing your things quite smartly. Thank you so much.